Okay then, so here we are in October, November 2023, paper 1-1. The diagram shows part of the graph y equals a cos x over b plus c, where a, b, and c are integers. We want to find the values of a, b, and c. Now, before I do this, I think I'm just going to talk in general terms about this kind of question. So usually we've got a form y equals a cos. Now, usually it's bx here. I'm just going to call it kx just to avoid any confusion with this question. Plus c. And basically what we want to do is we want to understand what each of these values, a, b, a, k, and c refer to. Now let's go in reverse order. Let's start with c. C is the shift in the y direction. And that basically tells you where is the center line of your cos graph. K here is a little bit different. It tells you the number of waves in 360 degrees, if you're dealing with sine and cosine. If it's tan, then it's the number of waves in 180 degrees. Now, this is related to the period, right? Because the period is the size of one wave. So how could we get the size of one wave? Well, we would do 360 degrees divided by the number of waves in 360 degrees, which in this case is k. We could say the time period is 360 degrees divided by k. What's this A here? A is the amplitude. Okay, so if we go back up and we have a look at our graph, we're going to say, well, what's the shift in the y direction? If we want to know the shift in the y direction, we're really asking ourselves the question, where is the center line? And the center line of this graph is the line y equals -5, right? So hopefully that should be clear. But if you're not sure about that, what you could do is you could take the peak value, which is -1, add it to the lowest value, which is -9. So -1 plus -9 is -10. And I divide it by 2, I'll get -5, right? So that's that's our value of c, right? C has got to be equal to -5. Now let's do our amplitude, right? So what's the size of our amplitude? Well, we go from here all the way up to -1. And so that is 4, isn't it, right? The distance between -1 and -5 is 4. We could also think about it the other way, going down from -5 to -9 is also 4. The amplitude there, A, is equal to 4. Now, what's this thing with getting B? Well, I want to think first in terms of the period. The period is the distance of one complete wave. So one complete wave is going to be that distance there, right? Because I start here, have one full wave like that, all the way to there. So how big is that period going to be? Well, it's going to be twice 540, isn't it, right? Because I start at -540, go all the way up to +540. And so I know the period t is equal to 1080 degrees. And what I said before is if one wave is 1080 degrees, then we can find out the k value, because that's going to be 360 degrees divided by 1080, okay, which is 1/3, right? Remember, what does k refer to? It refers to the number of waves in 360 degrees. So if we know that one wave takes 1080 degrees, then the number of waves in 360 is going to be a third of one wave, okay? We end up there with k is 3, but of course in this particular case, right, if we were to write this down, then we would say that y is equal to 4 cos a third x minus 5. So we're supposed to find b in this question, right? So they've rewritten it in kind of an awkward way. Instead of describing it as bx, they've described it as x upon b. In this case, b is not a third, b is in fact 3. So it's a little bit sneaky there, just changing it a little bit, but hopefully in a way that isn't too difficult to understand. Okay? All right. Okay then, question 2. A polynomial p of x is such that p of x is ax cubed minus 11x squared plus bx plus c, where a, b, and c are integers. P of x is divisible by x and has a remainder of 3/2 when divided by 2x plus 1. It is also given that p prime of 2 is equal to 18. We want to find the values of a, b, and c. Okay, then we just need to be nice and methodical. We've got 3 bits of information, right? P of x is divisible by x, has a remainder 3 upon 2 when divided by that, and we've also got this information here. So let's just go through one by one. If P of x is divisible by x, then what that means is that x is a factor. And if x is a factor, that means that we know that x equals 0 is a root. Okay? And therefore, if we were to substitute 0 into the polynomial, then what we should get is we should get 0, right? Because that's the definition of a root. So what I'm going to do is I'm going to substitute in, I'm going to get a times by 0 cubed minus 11, 0 squared, plus b times by 0 plus c will be equal to 0. And therefore, that means that c is equal to 0, right? So hopefully that's fairly straightforward. Okay, the next one, if we have a remainder of 3 upon 2 when we divide the polynomial by 2x plus 1, well, that means that if we were to substitute in negative a half into the polynomial, we will get 3 upon 2, right? So if we substitute in negative a half into our polynomial, we will get 3 upon 2, right? That is exactly what this statement here means. Now, if you're not sure about that, that is a statement of the remainder theorem. Remainder theorem basically states that if you divide the polynomial, let's say f of x, by x minus alpha, and you get a remainder of r, let's call it big R, then that means that if I was to substitute alpha into the polynomial, I will get that remainder r, right? So that's kind of the remainder theorem in short. Now, if you're wondering where the negative half comes from, basically what we can do is we can say, take that 2x plus 1 that we're dividing by, we're going to set it equal to 0. That means 2x is equal to negative 1, x is equal to negative a half. So if you're unsure about that, that's the reason we're substituting in negative a half into the polynomial and why we're going to get 3 upon 2. So then the rest of that is we're just going to substitute in. So if we substitute in negative half into our polynomial, we're going to get a times by negative a half cubed, which is going to be negative 1 upon 8. So we get negative an eighth a, minus 11 times by negative a half squared, which is positive a quarter, plus b times by negative a half, so that's minus a half b. C, remember, is 0, and this whole thing is going to be equal to 3 upon 2. Okay, guys, well, we've got fractions here, don't like fractions, and the best way to get rid of it is to multiply everything through by 8. So if I multiply through by 8, I'm going to get minus a minus 22 minus 4b is equal to 12. And so if I rearrange that, I get minus a minus 4b is equal to 34, okay? And it's probably easier to write that as a plus 4b is equal to minus 34, right? So that's one equation. Okay, now the next, or the last one is we've got this statement here that p prime of 2 is equal to 18. So firstly, we're going to have to differentiate our polynomial. So we've got p of x, I'm just going to rewrite it, is equal to, what was it? ax cubed minus 11x squared. So ax cubed minus 11x squared plus bx, and we can ignore the c because we know c is 0. Plus bx. Okay, now I know that I need to differentiate this. So if I differentiate, then what I'm going to get is 3ax squared minus 22x plus b. And the question tells me that if I substitute 2 into that, I should get 18, right? So just restate that. P prime of 2 is equal to 18. So let's substitute 2 in. I get 3a times by 2 squared, which is 4, minus 22 times by 2, which is 44, plus b is equal to 18. So 12a plus b is equal to 18 plus 44. What is that? 62, I think. Okay, so now what I've got is I've got two equations, don't I? I have got this equation here, which is equation 1, this equation here, which is equation 2, and I think we want to solve simultaneous. So what will I do? I think I will take the second equation and multiply it by 4. So I've got a plus 4b is equal to negative 34. Let's just rewrite that. A plus 4b is equal to negative 34. Yeah. And then I'm going to take the second equation and I'm going to multiply it by 4. I'm going to get 48a plus 4b is equal to 62 times by 4, which is 248, I think. And then what you notice is we can use the elimination method by subtracting one equation from the other, because that means that we can eliminate the two 4b's. Okay, so if we do a minus 48a, we're going to get minus 47a. And if we do minus 34 minus 248, what would that be? 278, 282, I think, minus 282. And so therefore, what we can do is we can divide both sides through by 47. And I'm going to use a calculator for that just to double check my working. Let me just get my calculator out. There it is. So 282 divided by 47 is 6. So I get there that a is equal to 6. Okay, like that. And if we've got a is equal to 6, well, we can substitute in, can't we? So substitute into 2, substitute into 2. And what we would get is we get 12 times by 6 plus b is equal to 62. 12 times by 6 is 72. So b is going to be 62 minus 72, which is negative 10. And so therefore, our polynomial will be ax cubed, so that's 6x cubed. 6x cubed, where is it? Minus 11x squared minus 10x. Okay, and that's our answer for part A. All right, then part B, hence write p of x as a product of 3 linear factors. Well, we've got p of x here, so I think first thing we can do is we can factorize out the x. We get p of x is equal to x bracket 6x squared minus 11x minus 10. So we've got a quadratic there which we can factorize. So x now, if we've got 6x squared, it can either be 6x and 1x, or it could be 3x and 2x. So I'm going to try 3x and 2x. And what we want is we want two numbers that are going to multiply together to give negative 10 to go here and here. But the numbers have also got to work in such a way that what we get is negative 11x. So to get negative 10, we're probably going to have 5 and 2. And so what's going to be the best way of doing that? I guess if this is minus 2 and no, this is plus 2 and this is minus 5, I think we'll get that because we'll have 3x times by negative 5, which is negative 15x, plus 2 times by 2x, which is plus 4x, and negative 15x plus 4x is negative 11x. So that should be our answer. X times by 3x plus 2 times by 2x minus 5. All right then, so question 3, which is a vectors question. The point A has position vector 2, negative 6. The point B has position vector negative 3, 6. Find in vector form the displacement of B from A. Well, there are a couple of things firstly to understand about this. Firstly, when we say this is position vector, it means that this guy here we refer to as OA, right? So that guy there is OA, this thing. And if this is the position vector for B, then this guy here is OB, right? So good to define it. So what we mean by a position vector is we mean a vector relative to the origin point O. The second thing then is if we want to find in vector form the displacement of B from A, well, if I was to kind of draw out the three positions, right? Here's O, here's A, here's B. Sorry, this is not to scale, right? It's not meant to represent the vectors. This guy is the vector OA. This guy here is the vector OB. What we're being asked to find is the displacement of B, this guy, from A. So that means that we've got this vector going in that direction, right? We're going from A to B. There are two marks here, basically. One is if you get either AB or BA, and the second mark, it seems to me, is whether you've got the right direction. So it's quite important you're able to understand how to interpret this thing, right? We are going to B from A. So A is our starting point, B is our ending point. Now, if that's the case, right, then hopefully it should be reasonably clear that we're finding the vector AB. The vector AB is the same as OB minus OA. Okay. If you're not sure about that, by the way, the vector AB, how could we think about it using this diagram? We could do A to O. Well, A to O is the same as negative OA. It's the same as that thing, plus OB. Right. So negative OA plus OB. All right, so let's just key in our values, I think. So OB is negative 3, 6. OA is 2, negative 6. So if we do that, we've got negative 3 minus 2, which is negative 5. And then 6 minus minus 6, which is 12. Okay, so that's our vector. Okay, then if we want to find the distance AB, well, the distance is just the magnitude of the displacement vector, right? So what we're being asked to do is to find the magnitude. And the magnitude is basically Pythagoras theorem. We are finding the square root of negative 5 squared plus 12 squared. And that's going to be 25 plus 144, which is 169. And if you square root that, you should get 13. Okay, so the distance is 13. All right, then, part C, the point X is such that 3 times by AB is equal to 2AX. Want to find the position vector of X. Again, what does it mean, position vector of X? It means the vector OX, right? We're going from O to X. So we can start by rearranging this. We can say that AX is equal to 3 upon 2 AB. And we've already calculated what AB is in the first part of the question, right? AB is the vector negative 5, 12. Right, so 3 upon 2, negative 5, 12. Okay, well, how can we use that to find the vector OX? Well, OX would be the same as the vector that takes us from O to A, and then the vector that takes us from A to X, right? I want to go O to X, it's the same as going O to A and then A to X. So I can now substitute in my vector OA, which is, what was it? 2, negative 6. This guy is 2, negative 6. And then I can substitute in AX, which is 3 upon 2 times by negative 5. So that's negative 15 upon 2. And then 3 upon 2 times by 12, which I think is 18, isn't it? Okay. So if I now combine these, I've got 2 plus minus 15 upon 2, which is 4 upon 2 minus 15 upon 2. Is that minus 11 upon 2? I'm just going to double check because I'm a bit tired today. My brain isn't working. Yeah, minus 11 upon 2. And I got minus 6 plus 18, which is 12. So the vector OX should be negative 11 upon 2, 12. I'm just going to quickly check the mark scheme, make sure I got that right. Yeah, that is right. Okay, we're in question 4. The table shows values of the variables x and y, which are related by this equation here, where a and b are constants. Want to use the data to draw a straight line graph of ln y against ln x. Well, it tells you what graph you want, right? So you already know you need to calculate ln x and ln y, so I've already done that. You don't need long decimal places, right? 1 or 2 decimal places should be fine. And what I've just done is I've plotted those points on the graph there to save a bit of time. And we'll need to draw a line that goes through those points. And so that line, I don't know, hopefully like that, should basically go through your points. Okay. All right. Part B is really the key thing of this question. We want to use our graph to estimate the values of A and B, giving our answers correct to 2 significant figures. All right, now then, the equation is y equals ax to the power of b. So let's just write that down. So y equals ax to the power of b. Now, if we log both sides, so we get ln y is equal to ln ax to the power of b, then we can use the logarithm rules to split apart the right-hand side. We can write that as ln a plus ln x to the power of b, like that. And then what can we do with this power here? Well, we can use another log rule to bring this down to the front. So we're going to write that guy as ln a plus b times by ln x. Now, if we just reorganize this a tiny bit, then what we're going to get is ln y is equal to b times by ln x plus ln a. Now, what is this? Well, b is a constant, remember, and a is a constant. That means that ln a is a constant. So we can rewrite our equation here as y is equal to mx plus c, where our capital Y variable is ln y, our capital X variable is ln x, and our gradient m is given by the constant b, and our y-intercept c is given by ln a. So basically, if we go back to our graph and we calculate the gradient should correspond to b, and the y-intercept should correspond to ln a. So let's do that. Let's go back to the graph. We're going to want to find our gradient. Well, probably the best way to find a gradient is to use the two most extreme points, right? That point and that point. So let's do that. The gradient m is going to be equal to, let's use our values, I think. I'm going to be using these values here and that value there. So 5.4 minus 3.0, the change in the y, over 1.61 minus 0 for the change in x. And I'm just going to calculate that on the calculator. 5.4 minus 3.0 divided by 1.61 is equal to 240 over 161, which is 1.49, which is roughly 1.5. Okay, and so remember what we said is the gradient is the same thing as our b value, so we can just write b is equal to 1.5. All right, then what about our y-intercept? Well, we know from the graph that that's our y-intercept is roughly 3. So our y-intercept, if we remember, is going to be equal to ln a. So we can just say, since c is equal to 3, ln a must be equal to 3. Therefore, a is equal to e to the power of 3. And e to the power of 3, if I just put it in my calculator, can I find where that is on my calculator? I hope so. Yep, e to the power of 3 is equal to 20.08. I don't know, 20.1 or maybe 20 is fine. Let me just check the mark scheme, see what they allow. It's probably a helpful thing to do. So 20 is what they've got. Okay, so just leave it like that, leave it as 20. Okay then, last part of this question, part C, we want to use our graph. Key thing here is we're using the graph to estimate the value of y when x is equal to 3.5. So what we need to do is we need to calculate what ln x is. So we want to calculate ln 3.5. So ln 3.5 is equal to 1.25. So that's going to be somewhere here, I think, 1.25. So we're going to draw a line that goes all the way up there, like that, to the graph. And then we want to read off what the ln y value is. That looks like 5. So our ln y value is equal to 5. Therefore, y is going to equal to e to the power of 5. And e to the power of 5 is equal to 148.4. And again, what I'll do is just look at the mark scheme, see what they want. They allow anything from 120 to 150. Okay, so it's quite a broad range. So 148 is perfectly adequate for that. Okay, and you'll probably get a better answer because your graphs will be nicer than mine because you're not trying to use a tablet. Okay. What else is on the mark scheme? Reading off the graph for ln x equals 1.25 to obtain ln y. So the key thing is you need to draw these lines here on your graph, right? You need to make it clear to the examiner that you have used that graph. Okay. Okay, then question 5, which is a classic permutations and combinations style question. We have a 4-digit code is to be formed from the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. No digit may be used more than once in any code, and a code may start with a 0. We want to find out how many codes can be formed. Okay, now before we do this question, usually what I want to do is I want to make sure we understand what we're using. Are we using permutations, NPR, or combinations, NCR? This is extremely important. So let's clarify what these guys mean. NPR is the number of ways to arrange R items taken from N items. And CR is the number of ways to choose R items taken from N items. So the key words here is arrange and choose. If we are arranging items, then it means that the order matters, right? So for permutations, order is important. For combinations, order is not important. And in the context of the question, we need to ask ourselves, does the order matter or not? Well, if we're forming a code, right, if we're creating a 4-digit code like, let's say, a bank code for your PIN number, then the number 2487 is going to be a different code to 7482, right? Even though those numbers are the same numbers, they're arranged in a different order, and therefore we consider it a different thing, right? When you key in your PIN number for your bank, you've not only got to have the right numbers, but you've got to have them in the right order as well. So in this question, because we're forming a code, what we say is that the order is important, and therefore we're going to be using permutations. Now then, we want to form a 4-digit code, 1, 2, 3, 4. How many digits have we got to choose from? We've got 10 digits here, right? 0, 1, all the way up to 9. How many digits do we want to choose? We want to choose 4. So we are arranging 4 digits taken from 10 digits. And so that is going to be 10p4, right? Arranging 4 digits taken from 10 digits. And if I put that into my calculator, I'm going to get 5040. Okay. All right, then, part 2. How many codes form an odd number? Well, let's say that we have, get rid of that. We could think of it like this. If we've got an odd number, then what can go in the last digit? Well, it can either be the number 1, or the number 3, or the number 5, or the number 7, or the number 9, right? So the way we think about this is to say, well, how many ways can I choose the last digit? There are 5 ways I can choose the last digit. Then what I've got to do is I've got to choose the remaining 3 digits, right? So what have I got? I've now got 9 digits to choose from instead of 10 because I've already used that 1 digit for the end. And instead of choosing 4 digits, I'm now going for 3. So this is going to be 5 times by 9p4, 9p3, beg your pardon, because I am arranging 3 digits taken from 9. That's 9p3. So if I was to multiply that out, let me just do that on my calculator. So 9p3, and I times it by 5, I get 2520. 2520. Now, if you're just wondering, by the way, why are we multiplying? The key word is the word and, right? And. We want both 3 digits at the beginning and a 4th odd digit at the end, right? We want both those things at the same time. So if we want something and something else, then we multiply. If we want something or something else, in other words, if we're considering 2 different alternatives, then we add, right? So and is we multiply, or is we add. Okay. All right, part 3. How many codes form a number greater than 1,000? Well, again, we just do this thing. If it's going to be greater than 1,000, then what numbers can go there? Well, we can have the number 1, 2, 3, 4, 5, 6, 7, 8, 9, right? In other words, there are a total of 9 digits that can go there. But then we also need to choose the remaining 3 digits. So let's just think about this. How many ways could I choose the first digit? There are 9 ways. The remaining digits, I've got 9 digits left over, and I need to arrange 3. That's going to be 9p3 again. And we're multiplying these because we want the first digit and these 3 at the end. So 9 times by 9p3, let me just do that. So 9p3 times by 9 is 4536. 4536. And that should be our answer for part 3. Okay, then part B of our permutations combinations question. A team of 9 people is to be chosen from a group of 15 people. The group includes a family of 4 people who must not be separated. Find the number of teams that can be chosen. Okay, now, as I said at the beginning, right, we really need to decide whether or not we're using permutations or combinations. And the key distinction between those is with permutations, we are arranging things, so order matters. With combinations, we are choosing things, order doesn't matter. There's already a massive clue which one we're using, which is the word chosen, which is stated here twice, isn't it? So chosen generally implies that we're going to be using combinations, but more importantly, we need to think about the context of the question. In this question, does order matter? Well, imagine I'm choosing a team of people, and I choose John, Paul, George, and Ringo. That would be the same thing as choosing George, Ringo, John, and Paul, or George, Ringo, Paul, and John, right? In other words, it doesn't matter the order in which I've got the people, so long as I've got those same people, right? That's the same team. So in this particular question, part B, the order doesn't matter. We're just choosing people. We're not arranging them. Therefore, we're using combinations. That's the first big thing. Now then, we've got a family of 4 people who must not be separated. And that means we've got 2 situations to consider, right? Firstly, if the family is in the team. And if the family is in the team, what that means is that we're supposed to have a team of 9 people. We've already got the 4 family members in the team. So what we've got to do is we've got to choose the remaining 5. Now, where are we going to choose the remaining 5 from? We're going to choose them from this group here. But remember, instead of 15 people, we've already chosen 4 people. So we've got 11 remaining. So what we're doing in this case is we are choosing 5 people from 11. And choosing 5 people from 11 people is 11C5. Okay? And the second situation to consider is if the family is not in the team. Okay? In the team, sorry. And if they're not in the team, then that means we've got to choose 9 people, right? We've got to choose 9 people because the 4 family members are not in that team. And where are we choosing those 9 people from? Well, we've got to choose them from 11 people. Why is that? Well, because we've got 15 people in total, but we cannot choose the 4 family members. So we've got 15 minus 4, which is 11 people to choose from. And now what we're doing is we're choosing 9. Okay, so if we were to calculate these, 11C5 is 462. And 11C9, that is 55. Now, the key thing here is to understand that these are 2 separate cases. It's either we have the family in the team or the family is not in the team. And as I said earlier, right, if we've got the word and, right, if we've got 2 things that happen at the same time, then basically we multiply. But if we've got the word or, then what we do is we add. So what we've got to do here is we've got to add our 2 different outcomes, 462 plus 55. And what we will get is 517. Okay, so here what we've got is we've got 517 different ways in which we can have this situation. Okay, question 6, which is a logarithm question. We want to write 3 log x minus a half log 4 plus 2 as a single logarithm to base 10. Firstly, just a quick notation thing, right? When we see lg log, it's a shorthand for log base 10. So these logarithms are already all base 10. Now, before doing this question, I think it's helpful to revise the logarithm rules, which are as follows. If I have got log a plus log b, that's equal to log a times b. If I've got log a minus log b, that's log a over b. And if I've got log a to the power of p, then that's equal to p log a. Now, in this case, hopefully what you can see is we can combine these logs using the second rule, right? Because we've got one log minus another log. But before we do that, we can't have any coefficients here, right? So we need to get rid of those coefficients, the 3 and the half. And the way we do that is we use the third log rule there. So let me just go down and then restate that. I'm going to rewrite 3 log x as log x cubed. And I'm going to rewrite the half log 4 as log 4 to the power of a half plus 2. Right? So I've rewritten that. Let's put an equal sign to show it's the same thing. Then what am I going to say? Well, I'm going to write this as log x to the power of 3. What's 4 to the power of a half? Well, the power of a half means the square root. So this thing is actually log 2. Okay, so 4 to the power half is the square root of 4, which is 2. Now this thing plus 2, well, there's one other thing which we can kind of remember, right? Which is if I've got log base a to the power of p, then that's just equal to p. So what I can do is I can rewrite my 2 here as being log base 10 to the power of 2, right? Because it's the same thing. And remember, of course, log base 10, the shorter way of writing that is just to say log LG. Okay, so now what I can do is I can combine these using my 2 log rules. So log x cubed minus log 2 is log x cubed over 2. And then I can rewrite this using the next log rule, which is log a plus log b is log a times b. This is log 10 squared, which is 100, times by x cubed upon 2, which is log 50 x cubed. Now, I know I took a bit of time there. I'm sure that many of you can do it much faster with like skipping over steps. So I just want to make sure that I covered all of the steps for those of you who are not very sure. Okay. Okay, part B of this logarithm question, we want to solve the following equation: 2 log base a4 minus 3 log base 4a minus 5 is equal to 0. Now, hopefully the first thing you notice is that these logarithms have got 2 different bases, base a and base 4. So we need to change one of these logarithms so that we've all got the same base. And in order to do that, we need to know the formula for the change of base, which is this. Imagine I've got log base ax, and I want to convert it to log base bx. And the way I do that is I divide through by log base ba, where a is the old base there. Now, if you're struggling to memorize that formula, basically on the right-hand side, the bases on the numerator and denominator are the same, right? That thing there. So the question then is, well, do we change this guy here, or do we change that guy? Now, what I would suggest is that the unknown variable, in this case a, it's not so helpful to have that on the base. So what I would do is I would change this guy here, the log base a4. So let's do that. If we've got log base a4, we want to convert that to have log base 4. So that's log base 4 all over log base 4a, right? So we got log base 4 of the old base there. Now log base 4 is just equal to 1. And so therefore we've got 1 over log base 4a. Okay, well that means that we can replace this into our equation. So we've got 2 times by 1 upon log base 4a minus 3 log base 4a minus 5, I think, is equal to 0. And I think that when you've got a situation like this, it's always best to use a substitution. So I'm going to do that. Let, I don't know, let u equal to log base 4a. And if that's the case, we've got 2 divided by u minus 3u minus 5 is equal to 0. We can multiply everything through by u. So we get 2 minus 3u squared minus 5u is equal to 0. And I'm just going to rearrange that a little bit. You get 3u squared plus 5u minus 2 is equal to 0. Hopefully you can see that that is a quadratic. And we can factorize that guy. So we get 3u times by u. And we're looking for two numbers that are going to go here and here that multiply together to give negative 2. So that'll be plus 2 and negative 1, or minus 2 and positive 1. But they need to combine in such a way that we get 5u. Well, I think the way that we're going to do that is with plus 2 and negative 1. The reason for that is 3u times by 2 is 6u. And then we're going to get negative 1 times by u, which is minus u. So 6u minus u is positive 5u. Well, if that's the case, then u is either equal to a third or u is equal to negative 2. But of course, we need to remember that u is log base 4a. So this guy is log base 4a is equal to a third, or log base 4a is equal to negative 2. So we're going to convert this to exponential form. A is equal to 4 to the power of a third, which is the same thing as the cube root of 4. This solution here is a is equal to 4 to the power of negative 2, which is the same thing as 1 divided by 4 squared, which is equal to 1 upon 16. Okay, now what I'm going to do is I'm just going to very quickly check the mark scheme to see if those are sufficient answers or whether we need to write them as decimals. So let me just go back to that. Yeah, no, they're happy with 1 upon 16 and 4 to the power of a third, right? So those solutions are adequate. All right, then here we are in question 7. A curve has equation y equals f of x, where f of x is 2x plus 1 times by 3x minus 2 all squared. We want to show that f prime x can be written in this form where p and q are integers. Well, okay, guys, if we want to differentiate this function, the first thing we need to understand is we've got to use the product rule. Why do we use the product rule? Because we have got the product of two functions, right? We've got this function here, 2x plus 1, multiplied by 3x minus 2 all squared, right? So we've got one function here and another function here. We're multiplying them, right? We've got the product of two functions. Therefore, we use the product rule, right? The word product rule, the name product rule is an appropriate name, basically. So I'm going to call the first function u, which is 2x plus 1. And the second function v is 3x minus 2 to the power of 2. And we've got to differentiate these. So u prime is just 2. V prime, well, we've got to use the chain rule. Right, so I've got to take that 2. I'm going to differentiate the big bracket. So bring the 2 down to the front and reduce that power of 2 by 1. So I get 2 bracket 3x minus 2 to the power of 1. And then what I do is I differentiate the bracket on the inside. So I differentiate 3x minus 2, I get 3. And so I multiply through by 3. Okay. Now then, what is the product rule? The product rule is v times by du dx plus u times by dv dx, or if I prefer to say v du plus u dv because it's a nice, fast, easy way to remember. Now, I'm pretty sure that most of your teachers in your textbooks say to remember it in the other order. They say u dv plus v du. The reason I write it in this order, the reason I encourage you to do it in this order is because that's the same order as the quotient rule, right? In the quotient rule, we have v du minus u dv, and there the order really matters for the quotient rule, because if you get it the wrong way round, you're going to get the wrong answer, okay? So since the quotient rule is v du minus u dv, I think to help you memorize, and not make as a mistake, remember the product rule as v du plus u dv, right? I think that's actually quite a helpful thing for you. All right, so let's substitute in. So we got v is 3x minus 2 all squared, du is 2, plus u, which is 2x plus 1, remember to write the brackets, times by 6 bracket 3x minus 2. And hopefully what you can see is we've got a common factor of 3x minus 2, right? This guy here and this guy here. So let's factorize that out. So we've got 3x minus 2, big bracket. I'll be left with 2 bracket 3x minus 2 plus 6 bracket 2x plus 1. So what I'm going to do is I'm just going to expand and collect terms. So 3x minus 2, right? 6x minus 4 plus 12x plus 6. And so then if I collect these terms, I'm going to get bracket 3x minus 2, bracket 6x plus 12x is 18x, minus 4 plus 6 is plus 2. And let's just check the form that the question wanted. It wanted to pull out a factor of 2, so let's pull out a factor of 2. So we've got 2, bracket 3x minus 2, bracket 9x plus 1. And so if we just go up and we compare, we've got the right answer, right? And P is what, 9, and Q is 1, right? So we want to just write that for the sake of the examiner. P is equal to 9, and Q is equal to 1. All right, then part B of this question, we want to find the coordinates of the stationary points on the curve. Well, what's the definition of a stationary point? A stationary point is a place where dy dx is equal to 0. So what we're going to do is we're going to take our equation for dy dx, which we found earlier, which is 2 bracket 3x minus 2 times by 9x plus 1, and we're going to set that equal to 0. Now, just to clarify for people who haven't really thought about this before, right? If I've got 3 things and I multiply them and I get 0, it means that either one of those things must be 0, right? So if I do 5 times by 0, I get 0. Or if I do 0 times by 3, I get 0, right? So if I've got things that multiply together that give me 0, it means that one of those things has to be 0. So either 3x minus 2 is 0, or 9x plus 1 is 0. I know for so many of you that's going to be like really, really obvious, but actually, you know, there are lots of students who get quite far in math and they haven't really understood that because it's never been stated, okay? All right, so x, if I rearrange, is going to be 2/3, and the other x is going to be minus 1/9, okay? Now then, we've got to be very careful with this question because it says find the coordinates, right? It doesn't say find the x coordinate. It means we also need to find the y coordinate. So we need to substitute that into our equation for y. And y was 2x plus 1 times by 3x minus 2 all squared. So 2x plus 1 is equal to 2x plus 1. And then what was it? Times by 3x minus 2 all squared. All right, now then, what we're going to do when x is equal to 2/3, then what are we going to get? Y is equal to 2 times by 2/3, which is 4/3, plus 1 times by 3 times by 2/3, which is 2, minus 2. Oh, that's interesting, all squared. Well, 2 minus 2 is 0, isn't it? So anything multiplied by 0 is 0. The y coordinate there is 0, which means that the stationary point is going to be 2/3, comma 0. That's one of the stationary points. Then the next one we've got to do is we're going to substitute in negative a ninth. So when x is equal to negative 1/9, then y is going to be equal to 2 times by that. So it's minus 2/9 plus 1 times by 3 times by negative a ninth, which is minus 1/3, minus 2 all squared. And I'm just going to simplify this, right? 1 is 9/9, right? So minus 2/9 plus 9/9 is 7/9. Okay. And negative 2 is the same as negative 6/3. So minus 1/3 minus 6/3 is minus 7/3. Okay. And I need to square that. So I'm going to get negative 7 squared is 49 times by another 7. So 7 to the power of 3 basically is 343. And 3 squared is 9. And then 9 times by 9 is 81. I get 343 upon 81. 343 upon 81. And that doesn't simplify. So my other coordinate is going to be negative a ninth, comma, 343 upon 81. Okay, and that should be my answer. Okay, then next part of this question. On the axis below, sketch the graph of y is equal to f of x, stating the intercepts with the coordinate axes. Okay, well, what we're going to be doing is we're going to be using the results from the previous parts of this question. Now, the first thing we should do is we should probably find out where the x-intercepts are. Well, the x-intercepts are where y is equal to 0, right? So either what we're going to have, let me just go over here. So x-intercept is when y is equal to 0. That means we're either going to get 2x plus 1 is equal to 0, which leads us to x is equal to negative a half. Or we're going to have 3x minus 2 is equal to 0, which means we're going to get x is equal to 2/3. But the thing is, right, that 2/3 is a repeated root. And so that means we're just going to be touching the axis at 2/3. Okay, so we can start by indicating that on straight away, I think. So that's, I don't know, 1/3, 2/3, 3/3, which is 1, negative a third, negative 2/3, negative 3/3. That's negative 1 there. So automatically we know that we have got an x-intercept at negative a half, so that's going to be there, and an x-intercept at 2/3, and that guy there is going to be a repeated root. How are we going to get our y-intercept? Our y-intercept is when x is 0. The y-intercept is when x is equal to 0. So how would we do that? Well, we substitute x is 0 into our function, right? So what we would get is here 0 plus 1, which is just 1, 0 minus 2, which is minus 2. We've got minus 2 all squared, which is 4, and then 4 times by 1 is just 4, right? So I will state that the y-intercept is 4, and I guess I'll just put 4 there, right? It doesn't have to be super accurate, really. So here's 4. And so we know that we're going to be going through there. All right. Okay, then, what else do we know about this graph? Well, we know it's a cubic graph. We know it's going to be a positive cubic if we multiplied it all out. So we know that the general shape of a positive cubic is that, whereas a negative cubic is that, right? The other way around. So we know that's going to be the general shape. We know that this is a repeated root, right? So we know we're just going to be touching there. And so we also know that we're going to be going down through here. But we need to use our coordinates for the stationary points, right? So the first stationary point, 2/3, 0, beg your pardon, 2/3, 0, is that guy. So we've already indicated that because we know that it's a double root, therefore we know it's kind of touching the graph, so it's a stationary point. But the other one is negative a ninth, comma 343 upon 81. Well, what's 343 divided by 81? Let's just see what that is as a decimal. That's 4.23. So where's that going to be? Well, negative a ninth, let's say that's kind of roughly there. And 4.23 is going to be sort of slightly higher. So let me just move that 4. That 4 is there. And our stationary point, therefore, is going to be a little bit higher. It's going to be sort of roughly there. So now what I can do is I think I can join up everything. So the graph's going to come up like that, right, like that. I'm going to touch the stationary point there. It's going to come back down. I'm going to go through the y-intercept. It's going to come back down a little bit more. I'm going to connect up here with this stationary point, which is also a repeated root. And it's going to go back up like that. The shape of my graph isn't super great, by the way. I think hopefully you can do better. You want to try to make it a kind of a smooth curve if you can. But that's basically the core idea, right? That's where it cuts the axes, and that's where the stationary points are. All right, then, last part D. I want to find the values of k such that the equation f of x equals k has 3 distinct roots or 3 distinct solutions. Well, what's the graph of y equals k? Y equals k is just a straight line. So the straight line could just go through here, right? Now, if the straight line does go through there, how many roots are there? 1, 2, 3, right? There are 3 roots. But now let's say that the straight line went through somewhere else. Let's say the straight line went through here. Well, then there's only going to be one root, which is at this point. What if the straight line went through here instead on the x-axis? There would be 2 roots, right? Because it's this one here and where it just touches there. And what about if it went through here? Again, there would be 2 roots where it touches the maximum point there and where it touches here. So basically, what do we require? For 3 roots, we want our line to be going between the kind of maximum point here to the minimum point here, right? So our curve, we want to have k to be less than the maximum point, which was 343 upon 81, and we want it to be greater than the minimum point, which is 0. Okay? All right. All right, we're in question 8. We've got a diagram which shows the line 1 minus 4x, which is that line there, which meets a curve here. That's 4x squared minus 6x minus 5 at the points A and B. And we've got a tangent to the curve at B, which is this line here. And it meets that horizontal line that passes through A at the point C. And what we want to do is want to find the point C. Okay, well, in order to find the coordinate C, we're going to need to know the equation of that tangent line and that straight line there. And in order to do that, the first thing we need to do is we need to find the coordinates of A and B, which are the intersection of the line and the curve. So we're going to start by solving some simultaneous equations. So let's do that. We want to set 4x squared minus 6x minus 5 equal to 1 minus 4x, right? So we set the curve equal to the line, and we're going to rearrange that to get 4x squared, add 4x to both sides, so we get minus 2x, subtract 1 from both sides, so we get minus 6 equal to 0. I think I can divide both sides by 2, so 2x squared minus x minus 3 is equal to 0. And we're going to want to factorize that. We're going to get a 2x and an x term. And we're going to be looking for 2 numbers that multiply together to give negative 3. That's going to be either positive 3 and negative 1 or negative 3 and positive 1. We want to choose them in such a way that we're going to get here a negative x. Well, I think the way we're going to do that is if that's negative 3 and that's positive 1, let's just double check that. If I get 2x times by 1, that's plus 2x. Negative 3 times by x is negative 3x, so 2x minus 3x is minus x. So that's going to leave us with 2 solutions. Either x is equal to 3 upon 2, or x is equal to negative 1. Okay, so we know the 2 x coordinates of our intersection, but of course we also want to find the y coordinate, which we can find by substituting into the line 1 minus 4x. So when x is equal to negative 1, y is equal to 1 minus 4x, which is 4 times by negative 1. And of course, minus 4 times by minus 1 is plus 4, and 1 plus 4 is 5. So that coordinate is going to be the coordinate negative 1 comma 5. We just go up to our diagram. That looks like that coordinate there, negative 1 comma 5. Okay. And if we substitute in x is equal to 3 upon 2, so when x is equal to 3 upon 2, y is equal to 1 minus 4 lots of 3 upon 2, which is going to be 2 times by 3, which is 6, and 1 minus 6 is minus 5. Okay, and so the second coordinate is going to be 3 upon 2, comma, negative 5. So let's just label that on. B is 3 upon 2, comma, negative 5. All right, then. Well, first of all, that enables us to know the equation of this line here, right? This line is just going to have the same coordinate. It is going to be the same as the y coordinate of A. So that line there is the line y equals positive 5. Okay. So now the thing we need to do is we need to find the equation of the tangent at B. And to find the equation of a tangent, we need two things. One is we need the coordinate point, which we've already got. And the second thing is we need the gradient at that point. The way we get the gradient is by differentiating the curve. So the curve is 4x squared minus 6x minus 5. So let's write that again. So y is equal to 4x squared minus 6x minus 5. Let's just go up, check that, 4x squared minus 6x minus 5. And differentiating this is going to tell us the gradient of the tangent. So that will be 8x minus 6. And we substitute the point we're interested in, which is 3 upon 2. So when x is equal to 3 upon 2, y prime is equal to 8 times by 3 upon 2 minus 6. And that's going to be the same as 4 times by 3, which is 12, minus 6, which is 6. We can say that the gradient of the tangent to the curve at that point is equal to 6. Well, if we've got the gradient of the tangent and we've got the point, we can find the equation of the curve by using the form y minus y1 is equal to m bracket x minus x1. Let's do that. Our y coordinate is negative 5, isn't it? So we've got, beg your pardon, we've got y minus minus 5 is equal to m, which is 6, x minus, our x coordinate I think was 3 upon 2. And now if we just expand this, we've got y plus 5 is equal to 6x minus 18 upon 2 minus 9. So we get y is equal to 6x minus 5, so that's going to be minus 14 there. So that's the equation of our tangent, y equals 6x minus 14. So let's just label that on. Y equals 6x minus 14. And of course, what we want to do is we want to find the intersection of this line here, y equals 5, and this line here, the tangent, 6x minus 14. I think probably the easiest thing to do is just quickly go to the right. The intersection of that is going to be 5 is equal to 6x minus 14. So if we rearrange that, we're going to get 19 is equal to 6x. So x is equal to 19 upon 6. And of course, the y coordinate is 5. So the coordinate of the point C should be 19 upon 6, comma 5. Okay? And we are asked to give our answer correct to 2 decimal places for the x coordinate. So let me just do that. So 19 divided by 6 is 3.17. I'll just write that, the x coordinate of C is equal to 3.17, which is what the question asks. All right, we're in question 9, which is an arithmetic geometric progression style question. The first 3 terms of an arithmetic progression, right? So we're told it's arithmetic, are these 3 things here. And we're told that theta is between 0 and pi by 2. Given that the 12th term of this progression is equal to this thing, find the exact value of theta. Now, the key thing is this is arithmetic progression. Arithmetic progression means we're adding the same thing each time. So I'm just going to hopefully make this a little bit easy to see. I'm going to say let u equal tan theta upon 2. If that's the case, then our progression is going to be minus 3u minus u and then u. So what is it that we're adding each time? Well, we're adding 2u, isn't it, right? That's the thing we're adding each time. So what we can say is our first term for this arithmetic progression is minus 3 tan theta upon 2. And what's our common difference? Our common difference is 2 lots of u, which is 2 lots of tan theta upon 2, right? So we know that we've got to be adding each term. We just got to figure out what we're adding. Okay, now we're told that the 12th term of this progression is this thing. Well, what's the formula for the nth term of a arithmetic progression? The nth term, un, is a plus n minus 1d. That's something that's given in your formula book. The formula's on the front cover, sorry. And so the 12th term, u12, is going to be a plus 11d. We can just substitute our expression for a and for d. So a is negative 3 tan theta upon 2 plus 11 times by 2 tan theta upon 2. And 11 times by 2 is 22, minus 3 is going to be 19 tan theta upon 2. And in the question, we're told that this is equal to 19 root 3 upon 3. So we've got 19 root 3 upon 3. And hopefully what you can see there is that the 19 is going to cancel off. And so we're left with tan theta upon 2 is equal to root 3 upon t. So tan theta upon 2 is equal to root 3 upon 3. Well, ordinarily I would maybe use a substitution here, say let u equal theta upon 2, but I think we probably don't really need to in this case. So I'm just going to use my calculator. So root 3 divided by 3, the tan inverse of that is pi by 6. What are we doing? We're using radians, aren't we? Yeah, so pi by 6. I can say that theta upon 2 is equal to pi by 6. And so therefore theta is equal to pi by 3. And let's just check the domain of values. Well, theta's got to be between 0 and pi by 2. And so pi by 3 looks like the right answer. And we don't need to find alternative answers by like adding or subtracting pi, right, from here to get other values as well, because that should be sufficient. Okay, so we don't need to do that. Okay, part 2, we want to find the exact value of the sum of 10 terms of this progression. We want to see the formula again. What's the sum of the first n terms of an arithmetic progression? It's n upon 2 brackets 2a plus n minus 1d. Again, that's given to you in the formulas on the front of your exam paper. So what we're going to need to do is we're going to need to substitute in the right terms. So S10 is the sum of the first 10 terms. It's going to be equal to 10 upon 2, 2a. Well, what was our a? Our a was negative 3 tan theta upon 2. We're going to get negative 3, sorry, negative 6, beg your pardon, tan theta upon 2 plus 10 minus 1, which is 9, times by d, and d was 2 tan theta upon 2. 9 times by 2 tan theta upon 2. Okay, well, if we simplify that, 10 upon 2 is 5. We've got minus 6 tan theta upon 2 plus 18 tan theta upon 2, which is 12 tan theta upon 2. And in the previous part of the question, we saw that tan theta upon 2 was equal to root 3 upon 3. So we can replace our answer here with root 3 upon 3. We get 5 times by 12 times by root 3 upon 3. And of course, we could cancel off by dividing top and bottom by 3. So that becomes 4. And so what we've got is 5 times by 4 times by root 3, which is 20 root 3. And I think we're asked to leave it as an exact answer. Yeah, we want to find the exact value, which means we need to use surds. So we have 20 root 3 as our answer. All right, part B of this question is now looking at a geometric progression, right? Geometric progression is one in which we are multiplying each time. And we've got these terms here, a 16th cosec to the power of 4 phi, a quarter cosec to the power of 2 phi, and so on, where phi is between minus pi by 2 and pi by 2. Now, given that the sum of the third and the fourth terms of this progression is 4, find the possible values of phi. Well, what we need to do is we want to find the first term and the common ratio. Well, the first term's fairly straightforward because it's just given in the question. It's a 16th cosec to the power of 4 phi. So let me write that. 1 upon 16 cosec to the power of 4 phi. How do we find the common ratio? Well, to find the common ratio, what we do is we can take the ratio of any two consecutive terms. So we can either do the second term divided by the first term, or we could do the third term divided by the second term. Now, I think probably it's going to be easier to do the latter. So let's do 1 divided by a quarter cosec squared phi. And of course, if we do that, then 1 divided by a quarter is 4. Right, so that's that. And cosec is defined as 1 divided by sine. So if we've got 1 divided by cosec, it's the same thing as sine. So we've got 4 sine squared phi is our common ratio. Now, we've got the sum of the third and the fourth term, so let's just recap what is the nth term of an geometric progression. The nth term of a geometric progression is a times by r to the power of n minus 1. Okay, so here what we've got is the third term, u3, plus the fourth term, u4, must be equal to 4. And what will the third term be? That will be ar to the power of 2. And the fourth term will be beg your pardon, ar to the power of 3 is going to be equal to 4. Well, we can factorize this, I think. So why don't we factorize it as ar squared bracket 1 plus r is equal to 4. And a is a 16th cosec to the power of 4 phi. So 1/16 cosec to the power of 4 phi. R is 4 sine squared phi, so let's write that out. Got 4 sine squared phi, and then all squared, times by 1 plus r, which is 4 sine squared phi, and that's going to be equal to 4. Okay, well, let's expand this guy out. So we got 1 upon 16 times by cosec to the power of 4 phi. If we expand this whole thing, then we're going to get 4 squared, which is 16, times by sine to the power of 4 phi, right? Because sine squared squared is sine to the power of 4. I think this is going to be the place where people are going to make the most errors. I think they'll forget to square the 4, right? So just be extra careful there. Times by 1 plus 4 sine squared phi is equal to 4. Now, what's going to happen here? Firstly, the 1 upon 16 and the 16, those guys are going to cancel. Next, remember that cosec is the same as 1 upon sine. So this thing is actually 1 upon sine to the power of 4 times by sine to the power of 4. So that is also going to cancel off, right? Those guys are going to disappear. So what we're going to be left with here is 1 plus 4 sine squared phi is equal to 4. And so if we were to rearrange that, we're going to get 4 sine squared phi is equal to 3. So sine squared phi is equal to 3 upon 4. And that's going to give us sine phi is equal to the square root. We're going to get plus or minus root 3 upon 2. And I think that's going to be another major error because there's quite a lot of working here already. You're going to get to kind of the last part of it and you're going to forget that you've got a plus or a minus. Okay, then, so what's the next step for us? Well, we need to find out what phi is, and phi can be between negative pi by 2 and positive pi by 2. How do we solve this? Well, we could use the graph. I'm going to be using, I think, the sort of the quadrant method or the unit circle method. So let me try to do that. I'm going to draw out my unit circle like this. And I'll try to make it nice if I can. Oh, that's okay, I guess. So that's a unit circle, a circle of radius 1. And on the unit circle, right, what does sine refer to? Sine refers to the y coordinate. So if we're trying to solve sine phi is equal to positive root 3 upon 2, what we're really trying to do is we're trying to find out where the y coordinate is root 3 upon 2. And so if I was to draw that along like this, then what I'm going to get is I'm going to get two solutions. I'm going to get one solution here, and I'm going to get another solution there. Now, this solution is going to be 60 degrees, or pi upon 3, and that solution is going to be pi minus pi upon 3, which is 2 pi upon 3, but that's too big for us. We're not interested in that. So phi could be equal to pi by 3. Now, if we want to find out where sine phi is equal to negative root 3 upon 2, what we're asking is where is the y coordinate equal to negative root 3 upon 2? And again, I can just draw a line that goes through there. So what points does that give us? It either gives us this point or this point. And that coordinate there is negative pi by 3. And this coordinate here is like negative 2 pi upon 3, but we're not interested in that because that's too far. So we've got another coordinate minus pi by 3. So those should be our two answers. Okay then, so we're in the last part of this question. We want to determine whether or not this progression has a sum to infinity. Now, when do we get a sum to infinity? We get a sum to infinity when we have a series in which each term is getting smaller and smaller and smaller. For example, if we've got 2 plus 1 plus a half plus a quarter plus an eighth, right? What's happening there is that each of the terms is getting smaller and smaller and smaller. And so if we keep adding up these terms, eventually what's going to happen is we're going to be adding 0, 0, 0, 0, 0. And so our summation reaches a limit. In order for the terms to be getting smaller, what we really need is for the common ratio to be less than 1, or the modulus of the common ratio to be less than 1. Because if that's the case, then the terms are not going to be getting bigger, but they're going to be getting smaller. So if we just go back to our question, right, where we just found that that phi is pi upon 3 or minus pi upon 3. So we just take that back to the common ratio, which was 4 sine squared phi. And we saw that sine squared phi was 3 upon 4. So our common ratio R was 4 sine squared phi, and sine squared phi was 3 upon 4, so we can write 4 times by 3 upon 4. What we get there is 3. Well, if the common ratio is 3, that's a number that's bigger than 1, therefore we do not have a sum to infinity. Because the terms are not getting smaller, and therefore we do not have a convergent series. Okay? All right, then here we are in question 10. We are given that y is equal to this function here. We want to show that dy dx can be written in this form where a and b are integers to be found. Now, the key thing here is we've got one function, the square root of 3x squared minus 2, divided by another function, which is x minus 4. And so we've got to use the quotient rule, right? We use the quotient rule when we've got one function divided by another function. So to do that, we're going to label the function on the top u. So I'm going to write that as 3x squared minus 2 to the power of a half, because remember, power of a half is the same thing as the square root. And I'm going to label v as the function on the bottom, which is x minus 4. Okay, then I've got to differentiate both of these. So if I differentiate u, I've got to use the chain rule. So I'm going to differentiate that big bracket first, this thing. So I take the half, bring it down to the front, reduce that power of a half by 1 to get negative a half. Then what I've got to do is I've got to differentiate inside the bracket, which will give me 6x. And so I multiply through by 6x. So I'll do that again. Big bracket, 3x squared minus 2. Subtract 1 from that power. Then look inside the bracket, differentiate. I get 6x, and I multiply through. V is differentiates a bit easier. Just get 1, right? Because 1x differentiated gives you 1, and negative 4 is a constant. Okay, then it's probably a good idea that we remember what the quotient rule is. Quotient rule is v du minus u dv all over v squared. So really what we've got to do here is just substitute our values in. So our value for v is x minus 4. And our value for u prime is a half bracket 3x squared minus 2 to the power of negative a half times by 6x. And we've got to subtract u dv. So that's 3x squared minus 2 to the power of a half times by 1 all over v squared, which is x minus 4 all squared. Okay, now if we're going to want to simplify this thing, generally what I would suggest is you look at the bracket term which has got a negative power, right? So that thing there's got a negative power. We want to get rid of that. How can we get rid of it? Well, we multiply everything through by the equivalent positive power. What I mean by that is we take the whole numerator and we're going to multiply it through by 3x squared minus 2 to the power of a half. If you think about that, it's kind of like we're cancelling out this term here. And of course, if we multiply the whole numerator by that, then we've also got to do the same thing to the denominator so that we've got equivalent fractions. Okay, so that's what I'm going to do. I'm going to multiply this thing here first by the 3x squared minus 2 to the power of half. And of course, if we do that, that term there is going to completely cancel off. So what we're going to be left with is x minus 4. The half can be times by the 6x, we just get 3x. And then, as I said, that term there cancels off and gives us 1. Now, if we multiply this term through, then what's going to happen is 3x squared minus 2 to the power of a half. If we times it by the same thing also to the power of a half, then what we've got to do is we've got to add these indices, and a half plus half is 1. So what we end up with is minus bracket 3x squared minus 2 to the power of 1. And then on the denominator, what we've got is x minus 4 all squared times by 3x squared minus 2 to the power of a half. And we could rewrite that as the square root of 3x squared minus 2. Okay, well, the top, we can expand the brackets and simplify, I think. So x times by 3x is 3x squared. Minus 4 times 3x is minus 12x. Minus 3x squared plus 2, all divided through by x minus 4 squared times by the square root of 3x squared minus 2. And if we've got 3x squared minus 3x squared on the top, then that cancels out with that. So we're left with minus 12x plus 2 on the top. Now, what was the form we needed? Okay, we just needed to get ax plus b. All right, so I can just simplify like that to give minus 12x plus 2, all divided through by x minus 4 squared times by the square root of 3x squared minus 2. And therefore, in that case, our a value is equal to negative 12, and our b value is equal to 2. And I think we've differentiated everything in the form that we want. Yep, okay, so that looks okay to me. All right, then, so we're in part B of this question, hence, right? So the keyword hence means we've got to use the answer to part A. Find in terms of h the approximate change in y when x increases from 3 to 3 plus h, where h is small. All right, well, the keyword here is approximate, which means we've got to use this relationship here, that delta y over delta x is approximately equal to dy dx, which is the gradient of the tangent at the starting point. And the starting point here is x is equal to 3, right? Because we're starting at that coordinate, x is 3, and we're moving a short distance to 3 plus h, okay? So this is our little increase in x, and so we can also say that delta x in this question is h, right? So delta x means a small increase in x. We're moving from x is 3 to x is 3 plus h. So that small increase in x is delta h. Well, our formula for dy dx we'd already found out, right? So dy dx is equal to, what was it? Negative 12x plus 2. All divided through by, what was it? X minus 4 squared times by the square root of 3x squared minus 2. So what we've got to do is we've got to substitute x is 3. So when x is equal to 3, the dy dx is going to be equal to minus 12 times by 3 is negative 36 plus 2 all over 3 minus 4 is negative 1. And negative 1 is going to be squared to give positive 1 times by the square root of 3 times by 3 squared. So 3 squared is 9, times by 3 is 27. 27 minus 2 is 25. And so 25 square roots to give 5. So negative 36 plus 2 is negative 34 over positive 1 times by 5. So you're going to get negative 34 upon 5. Okay, and so therefore we can just use the relationship and say, okay, delta y over delta x, which in this case is h, must be approximately equal to negative 34 upon 5. And so delta y is approximately equal to negative 34 upon 5 times by h. And what do we just leave the answer as? I will give it as a decimal as well. So 34 divided by 5 is 6.8. Approximately equal to negative 6.8 h. And that should be our answer.